factorizing quadratic trinomials. Whoa, whoa, that is a mouthful if I ever heard one. Well, each of them is huge, right? Let's break it down a bit. Factorizing means going from something like this, an expression, to two things multiplied together. So our answer is going to have brackets in there. It's going to be two things with brackets, multiplied. A quadratic means it's got something squared in it, like an x squared or a letter squared in it. And trinomials means that there are three terms. There's this term, and this term. Try, like a triangle. Okay, so that's the title, if the title was scaring you. But it's okay, I'll show you how to do it. It says to factorize each of the following, so to factorize this. Now we're going to use that secret that we learned before about sum and product. And it happens that if you have a quadratic, like x squared plus something x plus some constant, some number by itself, then the trick is to find two numbers that add together to give 11 and multiply to give 24. That's why it's called the sum and product trick, because this number is going to be the sum, they need to add to 11. And this number is going to be the product, they need to multiply to give 24. So I find it useful to list all the different pairs of numbers that can multiply to give 24. What's a pair of numbers you can multiply to give 24? Well, there are many answers. One answer is 1 times 24. Notice that for this, I'm going to put the sign in, the plus in, plus 1 times plus 24, just because later on there'll be some negative numbers, and I just want to make it really clear if the number is positive or negative. And sure enough, 1 times 24 gives 24, okay? So that matches the product. But what about the sum? Does 1 and 24 make 11 if we add them? No. It makes 25. So this is not the pair of numbers we want. We want to find a pair of numbers that add to give 11, multiply to give 24. Can you think of another pair of numbers? 2 times 12. Let's try that. If I do the sum of these things, I've got 2, positive 2, plus 12 gives me 14. Is that what I want? No, I wanted the sum to be 11. We can try some more, maybe 3 and 8. Notice that I'm trying to do this systematically, like in a system so that I get them all. 1, 2, 3, and then maybe I'd try 4. I'd skip 5 because 5 doesn't go into 24. Anyway, as long as you get all of them, that's the important thing. Or at least actually you don't even have to get all of them. You only have to get the one that matches. Does this one match? The product is 3 times 8, which is 24. The sum is 3 plus 8, which is 11. That's exactly what I want. So this is our winner. I didn't actually need to do this last one. This last one, is a pair of numbers. 4 times 6 gives 24. And if I add them, I get 10. But I've already found my answer. So once you've found your answer, you don't actually have to keep going and do the rest of the pairs. Yay, we got it. Once you've found your answer, you can jump straight to factorizing. Whew. Okay, so this looks like a bit of a mouthful again. This part here is just the question. Yeah, so I've said, therefore means because of all the stuff I've done, so therefore, this original question is the same as, and your answer for factorizing one of these is always going to look like x in brackets, plus or minus something, and then an x here, plus or minus something. What were the two factors that we need to write in? And two factors were positive 3, so that can go here, and positive 8. And this here is exactly the same as that quadratic. Yeah, I could go through and expand it. I'd have x times x, which is x squared, plus 3 times x. In fact, maybe I will just do that. Oh, no, I won't do that in the corner because my handwriting on a computer is terrible. Anyway, I'd have x squared plus 3 times x plus 3x plus 8x. That's 11x plus 3 times 8, which is 24. So if I expanded this, I would get that. So this and this are the same thing. So this one here and this one here are the same thing. They're just written a different way. Okay. Whew. All right. Ready for another one? I think we are. Let's try one with negatives, just to really throw a curveball. Remember this number here, it's the coefficient of x, the number in front of x. That is going to be our sum. and it includes the sign. Yeah, notice that it includes that minus sign. In here, it was positive 11. Here, the sum needs to be minus 5. Okay. And the product, well, what does the product need to be? The product needs to be positive 6. So I'm looking for two numbers that add to give minus 5, and they multiply to give positive 6. If I have two positive numbers, they're not going to add to give minus 5, all right? So we know that at least one of them has to be negative. I'm going to go through a whole bunch, but we'll see how we go. Let's try ones that we know won't work, okay? So I'm trying numbers that multiply to give 6. Numbers that multiply to give 6, well, I've got positive 1 times positive 6. They add together to give positive 7. Is this the sum that I'm looking for? No. So we need to keep going. Let's try negative 1 and negative 6. I'm starting to try negative numbers because this thing is negative. Negative 1 times negative 6 does give me the right product. That's good. If I do minus 1 subtract 6, what's the answer? Minus 7. Is that what I want? No, it's the wrong sum. Let's try negative 2 and negative 3. Sure enough, if I multiply these things, I get 6, positive 6, and that's why I came up with this factor pair. What is negative 2 subtract 3? Negative 5. That's a winner. That's a winner. That's the one that we wanted, right? It's got a product of positive 6 and a sum of negative 5. That's the magic. I don't need to do any more. I've found the two numbers that I need. So I can write therefore, and then I can write the original question. Your answer is always going to look like this. That's why I write this. So for these kinds of questions, it's always going to look kind of like this. That's why I write this little template, bracket X, and a little blank spot, end bracket, and a bracket X, and then a blank spot, because they're always going to look like that. The two magical numbers that did what we want are, well, what are the two numbers? Negative 2 is the first one, and the other one is negative 3. And that's our answer. And that is how you factorize quadratic trinomials. That is tricky, all right? It comes with a bit of practice, and especially with practice, you become quicker at finding the right factor pair. Eventually, you might even be able to do some of them just in your head to be able to figure it out. But to start with, I would just start to find the factor pair, list as many different pairs of numbers as you can that multiply to give this product, okay? If one of the numbers is negative, you know you're going to have to deal with some negative numbers in this factor pair. Okay. Anyway, I hope that this video has been helpful. Please ask me questions. I'm here to help. And yeah, good luck factorizing quadratic trinomials. Bye, everyone.